I think Shelby's didn't run. I tried to run yours last night. I tried to run Jairus's. We never could get that. I never could get that to run. So we can look at it again. But it's got a lot of stuff in there that I really don't want you all to have to deal with. I want you to learn logic and how to use a function. And when you try to use that pre-built send to Twitter or even send to email, I know you guys, that's great. Y'all spend a lot of time. I don't know how much time. I saw you had a lot of stuff in there. But what I really want you to do, the thing about chapter 3 was that you were supposed to be learning functions and how to pass parameters. And instead, we were trying to figure out why that function wouldn't work. So that's why I gave you the other problem in there. How many did that before class? Anybody? You did good. I'll look at yours. We'll look at a couple of them. I saw somebody that did it. I remember I looked at it, but it's real straightforward. And so we're going to look at that problem, which is what the last part of chapter 3 was really about, was using a function and passing parameters, or sometimes they're called arguments, into the function. Whereas the earlier part of the chapter, what we did was we did a voided function. What's a void function? If I remember, talks about a void function at the beginning of chapter 3. What does the word void mean? No, nothing, right? So what it meant was that you make a call to a function, you don't pass anything into it, and you don't return anything. You do everything in that function. So if you needed to print out something, you printed it inside the function instead of returning a value. And then we did a program in here in chapter 3 where we returned a value. That was all to do with the one where we calculated or went out to the website and got a price of coffee beans. You remember that? And so we had a function, and we'll look at that here, called get price. That first time we did it, it was a voided function. We didn't pass any value into it, and we didn't return anything. So let's go to one of them that, let's see, I had, here's where I'll open one up. I got some here so we can kind of review what we did. That here. We did this one, but I think that was not, okay, maybe it's in here. I bet it's 3. Yeah, here it is. Okay, this is the one where we did it with, I think, the voided function. Let me open it here. I'm going to put that down for a second. Open. Takes me a couple of minutes here to get to it. Here, 3. I'm pretty sure it's this one that does the voided function. Yes. Okay, this is the one that was in the beginning of chapter 3. And you remember the purpose of a function is simply if you have code that you want to reuse, then you don't have to copy and paste it twice or 3 times into the function. So when we originally wrote this program, all of this code was part of the main part of the program. The way it's written here, it's void because there's nothing in the brackets and there's no return statement. So that means that this call to the function get price, everything is done inside the function, even the print, right? So that's a voided function. And still, we're not dealing with if then else's right here, and we're not dealing with loops. This is just procedure, sequential steps through the function. But then the next one was to, let me see if this is it. I can't remember if I did it here. Oops. The next one is going to return a value. That's the next step in that it covered in our book. I think it's this one. Oh, this is the one that already has that Twitter thing in it. And I never did get it to work. So this is the one, though, this part. Okay, I'm going to take all this out. Okay, so with this one, it's going to return a value. The way I know that is because at the bottom of the function, it says return this. So if the price now is the same as Y, it's going to return the value. Actually, this one's not set up for return either. Here it is down here. Okay. Get this out. Is that where we got the sleep? Let's see. So this one, when it goes, I actually should say here also to say equals. I really need that here also. Oh, no, I don't, because it's going to return it and print it. Here, do I need that? I do have an if then else in this part. Oops. Get price. Oh, I see what it did. Okay, wait. This should work. If you guys see something that I'm coding wrong that might not work, tell me, guys back there. Any of you guys see something that might not work, we'll try it and then we'll correct it. Unexpected indent. See, I've never worked with a language before that cared about the indents. That's really strange to me. Let's see. Okay. I guess because, oops. Because you always indent it if else's, or this one does have a while loop in it too. So this one, it does have everything that we learned in chapter 1 also. Okay, if I put yes, it printed out the price. But then the while loop only works. Let me run it again. So that part worked. Let's see if I put no, if that part will work. No. Okay, it doesn't like my time.sleep time. Oh, okay. I didn't import. What is that called, guys? Import time. Okay. Import time, because it didn't know. And we never do that anyway. I only do like 1 or something like that. Okay, so this one, now will it work? Print. There I said print price, and then it says print by when it drops out of the loop. Didn't we change this too? Seems like we did, because it never hardly gets to 590, so we did something like 545, so it would actually come out. So now if I go run module. Oh, I did it backwards, didn't I? Needed to. Oh, it finally got out. So it stayed in the loop asking that website what the cost of the beans were, and it kept changing the price, and as soon as it was below 545, it dropped out and said buy them now. So this one actually does use the if then else code. If here, then do this, and then it'd drop out. Else, while it's 545 or less, then it's going to keep asking for the price, going up here to get price and asking for the price. So this one shows us 2 ways to use a function. Or this problem did, we saw a voided function, and this one still doesn't have anything in the parentheses, so that means it's not passing any kind of parameters. And what you usually, sometimes in our book, I think it tells you it's either parameters or arguments. But in every programming language, those terms are synonymous in a function, parameters and argument. Some people call one, the one that you pass an argument, and the one that receives it a parameter. Sometimes they do that, but they're really one and the same. So here we're not passing any values into get price. So it's going out here and going to that website and finding the price of coffee beans every few seconds, however long we tell it to wait. There, I only had it wait 1 second. And so then it finds in that array of data, of characters, that's what that's telling it. It finds the $sign, and then it goes to past that to do start a price and end a price. And so it passes this back into, well, here it's just prints it out. Down here, it keeps that value doing it. It puts it in price, prints it out to price, to the screen, and then at the very end, when it gets below, it drops it out. So this is just showing a return value. That's the most common way that a function's used, is where you use it maybe as a print routine, little things like somebody did one where they did a function for in that tax problem. They did one that calculated the tax and one that calculated the tip on a restaurant. Who did that? Can't remember. I graded one this morning that was doing that, which was, they used functions, which is really good. But what you need to understand is here, the program, when it runs, it's going to look at those two statements, then it just ignores that that's there. This is where the program actually starts, and it doesn't execute this code until there's a call to it. Okay? And one thing that I wanted to show you all today too, because I don't know if you've gone back out to Code Academy or not, but there is one that is really good on functions. It just doesn't give you a lot of practice, but it shows you a voided function, one that's a return, and let's see if I can get down to where. Oh, I guess I have to click on Python first, and then it shows me. Okay, so I'm going to go just to the Python part where I can start at the function. See, we did this one, but here's functions. You can go just to the functions, and these are calling functions, but let me go to where it shows me. Here's function junction. What this one shows you is the ones where it's just defined as a voided function. And one thing that was kind of funny here is that it has comment inside the function. If you're using quotes, you have to use triple quotes to make this not actually happen. If I save and submit this code, it comes, that's what it does, eggs, none. It printed that to the screen. So in that function, in Code Academy, what it's telling you in function, the first part is it says the header, which includes the DEF, which stands for define keyword, the name of the function, and any parameters that the function requires. And here's an example, and here it says there are no parameters if the parentheses are emptied. An optional comment that explains what the function does. And that's what was at the beginning of this one. Let's find it. Let me start it again. But then here is the comment. So you have to use triple quotes inside a function. And what is that, logic, or is that a specific language syntax? What tells you that you have to do triple? What language are we in? Python, right? So that's a Python rule. It's not a logic rule. When we do comments, now you guys that know Python really well, do we have to do that in idle to do a comment? I don't think you did, because you did one in a fun. Let's try that. That may be a Code Academy thing, but I don't think so. Let's see. If I go in here and I put a comment and say, yep, that's a comment then. Because see, I don't have the end one. See, like Laura saw how that changed color? That's saying, okay, everything after this is all comments, and it won't run until I put the comment in there and end it in triple. So I'll say this gets, oops,
What's the difference between the comment and the notes with the pound sign?
With the pound sign, it is not in a function.
I think it can be.
Yeah, with the pound sign, it's just per line.
But with the triple quotes, it can do
Multiple lines. Okay.
Oh, okay.
So that's, yeah, in JavaScript, I think someday I'm going to teach both of those in here because JavaScript's more like real languages. In JavaScript, you do a double slash for a single line comment. And for a multiple line comment in JavaScript, you do a slash asterisk, and then you end it however many lines down in an asterisk. So every language has their specific rules. So what they're saying is that you only have to use, so they, in Code Academy, they were doing that, and it wasn't a multiple line. They were just using triple quotes, I guess. So if you're doing multiple, let me try this in here, because I thought you guys did use, let's see if this works. This is function to get, oops, can't even type, price, oh, I still didn't do it right, price of, okay, so that should be the comment, right? It is in red. But that's why the triple quotes made all of it green, because it was going to do a multiple line comment, right? So if I saved this, it shouldn't do anything to my running. Yeah, it's going to work. So I can do it then. This is a single line quote, but if I wanted to do multiple lines, I'm sorry, comment, not quote. If I wanted to do a multiple line comment, which sometimes there was one student in my online that liked to put their pseudocode in their Python, which I used to do that in JavaScript too. And then you could see it at the top or the bottom and convert it to the language. You would want to use that multiple line maybe for that if you were doing that way. Okay. All right. So there are several things here, though. The one that is good too is the one here, parameters and arguments. And this one shows you exactly how to do that in Python, because in this one they used a function called power, and it had two parameters or arguments, base and exponent. Now see, this one's going to a second line. It's a comment. Add your parameters here. It may not really. It may just be that editor's making it come around. But that says result equals base, and that means exponent. Yeah, and exponent print. And here's where it's going to print that out, base, exponent, and result. So it doesn't return a value in this call, but it does pass two values or two parameters into the function. Okay, so this one shows you those three things that we learned in chapter 3, and you're not responsible for that send to Twitter thing. You do not have to try to work on that. And then at the end on Evernote, what I was telling you all, let's see, oh, I must have closed out the D2L. I'll just pull it up here. Okay, so on Evernote at the bottom, and I haven't shown one of the test question ones. I was going to do that too. I'll go over our test so that you'll know whether you got it the right problem or not. Then I was going to go ahead and create a flow chart using Lucidchart and make sure that the correct shapes are used. But really in this class, I may have had one or two that didn't do their flow chart. I can't remember. And if it's because you don't know for sure how to do Lucidchart, just let me know and I'll go through one in class. But one thing that some students were doing, I noticed, is on their flow chart, they were doing, and I can't remember if it's this class for sure, but they would do the beginning one, And then like on the desk and lamps, they would split it here and go input the desk and go over here and input the lamps. And then they made the calculations separate too, like one here and one over here. Well, this represents a branch. And so you don't want to ever code a flow chart unless it has an if else with a branch. So what you wanted to do was put both inputs either in one box, or you could have two input boxes. But the simple way was to have your input here, and all you have to do in a flowchart and pseudocode, and I was going to show you one that was a little simpler, get whatever the input is, whatever you call the variables, and then, or you can say input, whatever your variable names are, and then you should have a processing step, which is the calculation, and then another output parallelogram here, and then your end, okay? Basically, there may be 2 or 3 processing steps. There may be more than one input, but usually there's only one output. And then we also saw, is it in our book, or was it over there, where there's a box, since we're doing functions now, that looks like this, and that would go here, and then it would know, then you would start a separate flow chart over here where like our print one was what, went to a website, so it was get something, and then it was a process, and if it didn't have a return, then it printed here and stopped, and it would go right back to where, like if that was your predefined process. That's how you would do it. Because this one didn't have a function, your test or your project. But then we did one, I think this one that I gave you was. And if you're having any kind of struggles like with variables, understanding exactly what variables are, or any of these things that we've covered, there's also, has anybody ever used Khan Academy? Khan Academy, it has a lot of stuff in there, like even for math and different things. Saul Khan started tutoring students online, and it became an incredible business for him. And he's been on all kinds of the news channels and stuff because he's developed, and it's free. You can create a login in there, and there's tutorials, and he uses JavaScript to teach logic. So that's another one that I used last semester, but I didn't this semester because it was strictly JavaScript that he does. Okay, so I wanted to next go through, first I'll bring up one of the test problems that, I can't remember if this was Shelby's, I can't remember whose it was. If I can get it open again. Oh, did I? Maybe I minimized it. There it is. Okay, this one, I think it was Shelby's because he did a lot of comments, and also he used constants, and I did not require that on this test. I did not count it incorrect if you did not, but I want to be sure that you understand constants, because on the next projects and test, I want you to use constants if they're applicable, okay? What makes a variable a constant? Why would you want to use a constant?
It makes it easier if you got to change something later on.
Great. And so if they give you in the problem specific values for a variable, then that's the time that you want to use a constant. And this is the standard that we use. You don't have to use all caps, but it makes it easier at a glance to see, oh, hey, these are constants because they're all caps, okay? And so that's what he did here, and he commented it. Remember, anything in red is a comment. So he said, these are my constants, because in the problem, it gave you the credit hour dollar amount, and he put it in as a float because he wanted to be sure that it would carry out the decimal to the cents on the final cost. Then the fees were also a floated amount, And then he printed the constants, telling the user this is what will come up to the screen. And he formatted them. This is a format in Python. Then here's his user input. Hours equals input, and then his calculations. Now, some people, which it doesn't matter, go ahead and change this to float in a separate statement. But he did it here. So he said credit hour times float time. He's changing this string to numeric float. And then cost equals cost plus fees. And when he prints it out, by formatting it as a float, it went ahead and, well, it's really because all of these were floats, so it went ahead and determined that it was a float. Yes?
On that dollar mark percentage 0.2F, can you explain that to me again? Because
Sure.
I know that's what
Percentage is a placeholder. And so it's holding the place for the variable that it follows.
Okay.
And then the 2F simply says format it with 2 decimal places. That's
Okay.
what .2F, if you put 3F for it, it would carry it out, okay?
Okay.
That's why the 2F,
That makes sense.
all right? And so it's saying, find the percent sign and replace it with the variable that is right behind it and format it this way. And then the /n, everybody know what that is, except for, I guess, a couple of y'all that used it. That means go to a new line. So when we run it, this should go on another line.
Oh, that's how they do it.
Uh-huh. And then the other thing that some of them have used is a /t, which will tab it over to the center. So if, yes,
Does that mean it goes over 2 lines then?
yes, that one should go drop 2 lines.
Drop 2
Let's
lines.
run it and see that's what happened. So this one, if I put 12 in, and see, it did drop down 2 lines. And now if we also put a /t, whoops. Uh-oh. Why isn't my mouse coming down there? Well, it's not letting me come down there very well. So I'll do it this way. Let's see. Now if I say 12, and you see it tabbed it over. So you could, if you want it way in the center, you could put more tabs in there. That's, Python has you format pretty simple. And JavaScript, it was a little harder to format and things. Because with JavaScript, another difference in JavaScript is you don't have an interface like idle. You don't have that. You code it like in a text editor, and then you open it in a browser window to run it to see if it works. Because it's really surrounded with HTML, and that's how some people format the JavaScript. So, but Python is, in some ways, it's a little more straightforward, I guess. Now, I think also there was a couple of different ones that I wanted to show the pseudocode, because I have really never covered that, and it doesn't cover it in our book. But there were a couple people that did it exactly as if we were in the old book. Let me see. Where did I do that? I think, Shelby, I'm trying to remember. You did yours, and then there was yours had a little more words than you had to, but it worked. I mean, I didn't cut anything off for it, but I'm trying to remember who had like 4 or 5 lines. Maybe it was yours, Chris. I don't know. You did pseudocode and flowchart, right? Where was yours? Because I've graded yours too. Where was it at? T1. Let me see what yours did. Except for, yeah, you didn't want it. This, you're not actually getting as input. So you really only had 1 input. So that one should just say declare. So I guess it wasn't. Let me see. Was it Charles? I think it was. Is Charles in here?
Yeah.
You're right there. Okay. I think maybe it was your pseudocode. Was it on here? You did a loop or something. No.
Yeah, I'll take that.
No, that one probably, yeah, and I had to play with yours to get it to run. I forget what I did. See what this one is. Maybe it was this one. Start. Oh yeah, here's a pretty good one right here. Forget who this is. This might be somebody in my online. I can't remember. Oh, I was going to make it bigger, and it probably view. Oh, there we go. All right. So with this one, what they had was a start and an end, and I don't really care if you have a start and an end, but that's how we used to code in our old book, the pseudocode. But really what he said is print semester hour rates and fees. You can say that. You can say, we used to say declare constants. You could just simply say declare constants. And then you would say ask how many credits. So you could say input or get here, either way. And then here's, actually you just need to put this actual statement that you're going to code in Python here. And then add semester fees to hourly total. You don't have to write the words out. But this is all the lines you need in pseudocode. And the same thing, that isn't really the one I was going to show you, but I can't seem to, I thought I had it. That's not correct. Garrett, maybe it was Garrett's. Garrett's here too. So this one's pretty good. This one, again, you would want to just put the actual calculation here. You could just say num1 times 79, and whatever your variable is here that you're going to print out. Sum equals, that's all the pseudocode has to do. Pseudocode tells me, and the flowchart, even if you don't get Python working, it tells me if you understand the problem logically. Okay, that's the purpose of having you do the pseudocode and flowchart, because even if you have some problems with the syntax in Python, if I see that you understand the logic and how to set up variables, that's what I'm trying to get you to do in here. Okay, so that's the, you don't say, well, if I can do the Python, why do I need to do that? Well, that's the reason. If you can't get the Python working, then I at least know that you understand the logic behind solving the problem. Let's see.
So how would you write a pseudocode if, you know, let's say you had constants at the very beginning? How would you write that in a flowchart
or pseudocode? Okay, let's look at that problem that we were supposed to do today. And I can't remember if it had constants though. Let me look. Okay, this one is down at the bottom. Where did that go? It's right here. Okay, let me bring it up. I think it'll show that. Oh, that's pretty small, isn't it? Okay, here it is. But it's not letting me bring it over. I'm just going to open it. Okay, this one, what did I call that? Oh, I remember, CH3. Here, here. Okay, this one would be, I think I put it in here. Yeah, there it is. Oh, that's the answer. There it is. Okay, so for this one, what it wanted you to do, is this is the problem for defining a function using Python, and it replaces your Twitter problem in chapter 3. So you're to create the logic for a program that calculates and displays the amount of money you would have if you invested $5,000 at 3% interest for 1 year. And you were to create a separate method to do the calculation and display the result. You did this one, didn't you, Charles?
I started, yes.
I thought that was, maybe I looked at 2 or 3 of them. Who else said they did it? Marcus did it and Jairus did it. Okay. Okay, so I gave you the pseudocode, and this is all you have to do for pseudocode. This one actually, It should have, let me open the Word doc so I can change it a little bit. In the pseudocode, actually my constants would have been here, Cole, and they should be all caps. So I'm going to change that. Interest equals 0.03. Principal. So I just went ahead and declared my constants, and up here I could say like this, declare constants. Now up at the top is where my function is defined. So when I pass these, I have to pass these as all caps too. Or it won't know. Oops. Put it over there. This is what your pseudocode should actually, all your variables are very important in your pseudocode. Okay, so output, and you could use print if you want, output balance. So here it's going to make a call to this function. Now, do they have to be all caps up here when I pass it? What do you think? In Python, do they have to be identical, my parameters?
I don't think so.
No.
It's not supposed to. So let's see, because I could actually just use paren and int as long as I change it down in my function to be those variables. I could say paren int that way, because this is a call. Okay, so is this a voided function? What kind of function is this? Is it a voided? Is no, because I have something between these parentheses, right? If the parentheses are empty, then it's a void function, right? All right, so this one, the program actually would start here. It would declare this constant, and then it would make a call to a function called compute balance, and it's going to pass two parameters. Python or any language does not care what you call these or what you call them here. All it's saying is you have to have the same number of parameters. If I had just one here and two up here, it would give you an error, okay? So you have to have the same number of parameters, so it's going to take whatever's in the first one, dump it into there, take whatever's in the second one and dump it into this variable, okay? And then in the function, it is calculating the principal or the balance, and then it says return balance, so that's going to go into here, and those could be different names also. It's just going to return it into whatever's on the right side of the equal sign. It's going to dump into the left side of the equal sign. Okay.
So if you were going to do a flow chart and you had constants in it, what shape would you put in it?
Oh, the constants? Okay, the constants would go in a process box because you're defining something. It's like you're not asking for input. Make sense? So you only use the parallelogram if you're asking for input or if you're printing out something or displaying something to the screen or to the printer. Anybody else? So that would mean, and the function would be in the predefined box. Let's go to Lucid Chart and we can do that. So if we were doing a flow chart, and you know, there may not be very many times that you are required to do a flow chart, but if you go to, maybe you got a job at one of the big major corporations that has had programs in their system for years and years. Well, in their documentation, they may have flow charts because that used to be a really common way to design a program. And so if you know how to do this, then you won't have any problems. And I have all caps. So if I log in here and I want to look at that one, the way the big thing I want to look for from here on out when you do a project or a test and you're doing pseudocode in a flowchart, you want to be sure that your variables carry through. Whatever you decide your variables are in your flowchart or pseudocode, use those same variable names in your Python, okay? Variable names are really important. Okay, so I'm going to go to create. Oh, I don't want that over here. Come on. I think it's a little bit slow, our Wi-Fi. Okay, so if I'm doing a blank flowchart, okay, I've already got a start there. I didn't know I had this in here. So my process box could be my declaration for my variables. So I'm going to go over here and say, go to the left, go to the top, make it bigger. I'll see, about like that. Say, declare. I don't have to put this comment in there, but if you want to, you can. Then I would go down and say what was one of them was interest. It's supposed to be all caps. Probably gonna have to make it a little bit smaller. Oops, still didn't get it all caps. Equals 0.03. Then I had, what was my other constant? As principal, right? Principal equals 5,000, right? And so there I've declared my constants. So now I want, do I have input first? What was next? Oh, hell, what was next? Okay, my calculation, right? After I declared my constants, then I have my calculation. So what kind of box do I need? There's no input on this problem, right? So I use the same, right? A process box. Okay. Try to make them look about the same. Maybe not as big. Oh, actually, I'm going to put this one in the center because it's just going to be one statement, right? But I may need it smaller text to get it all on one line. So on this one, I said balance. Oops, not capitals though. This is a balance equals, and what's the name of my function? So it'd say balance equals compute balance. And then I'm going to pass parameters. Oops. Let's see if it'll let me. I would probably have to go, let me do this. Let me do this. Okay. See if it'll let me do it this way. Yeah, I'll just do. Okay, compute balance, and the parameters would be principal, comma, interest. Right. Okay, so now what's the next step? What do I do last? Output. Okay, so I need, oh, actually not output. I have to show a box. I've done that wrong because I have to show a, where is the one? I guess there's the predefined process. Some of them show it in a shape across the top. This one actually, well, no, this is not a predefined. Where's the one? Do they not show it? There, maybe it's down here. A swim lane. Shapes. Well, they may not have the function box. Manual input. They do on. We may have to use the predefined process, but predefined is really talking about one that is pre-built. So this is actually saying, yeah, I don't think I need this. Shh, you guys. I have to go out of class talk. Okay, so this one is, if I was doing the function for this one, this is the one that says compute balance, is what it's called. Balance equals, oh, I still could have left that in there, I guess, but just put it in. Okay, so here I would say balance equals compute balance. Oh, and I did all caps again. Balance equals compute balance, only this doesn't have a capital. Compute balance, and then it goes, you guys have to quit talking. Principal, comma, and then it's interest. Okay, there we go. I think that's right, but let me do this. Oops, that didn't work. There it is. Okay, so this is the predefined box, and the one that, if you use Visio, it's going to have one that has a line across the top. Okay, I don't know why that's doing that. Okay, so then once you do that, then you have your output box. Is this one got a return? I guess it's making me sign in for some reason. Remember what my login is. Do that. There it is. Okay, so on the next step, I have my output box. What if one of these was that? No. Graphic, metrics. No, it didn't do it either. All right, so that one will work. And then the last thing, let's look at our pseudocode. Okay, so we're going to return the balance back here. So our print statement is going to be in our main program. So I need the parallelogram data. And so this one is just going to say print balance. Make it a little bit larger. Oops. Print balance. Okay, now if I want an end one, that's this one. Is the terminator, says end. Now I can connect all these all the way down to make my flow chart to see the flow. Oops, that one went crooked. This one's probably going to go crooked also. And I could line those up if once I get them connected, I can line them up if I want. Oops. Has anyone ever used Visio? You have? I think that's a lot harder than this Lucy chart. But I wish it had, I know that's not the right one. Okay, then there's one other thing that we have to do. What is the other thing? We have to define the function, which is right here, right? So we have to go over next to where our main program is, and we have another little start. Or actually, this can just say compute balance, because that's what you're doing. Compute. That's the name of the function. Compute balance. And so the way that works, it just, does it have any input? Look back at our pseudocode, no input, right? It only has this statement. Command C. And so now it has a process box. And there that is. And then it has a return. And so that would be another, we can do that with the terminal. I'll have to look back at my old book to see for sure. This one is return. That actually says return, but then we need to have one in the above that. Oh, not that far. I want to have one above that that does do the output. Actually, it's just another process because it just goes, it doesn't output, it just returns. Return balance. You can do it in a separate box, or I would also accept if you just put return balance in this one. So then we just connect them together. Oops. Okay, so what happens, this is the flow chart then for this pseudocode. And so now if we write the Python, let's see, who said they had, Jairus did it? I can't remember who else. Marcus. Let's see, let me go back here. Is it in chapter 3? Just okay. Balance, right? Okay, I'm going to download. Okay, very straightforward. Just exactly like your pseudocode. The only difference is when we declared our constants, we put the, but his matches exactly the pseudocode before we changed it to be all caps, which is exactly what you want to do. You want your pseudocode to look just like what your, as close to it without having all the syntax in there, okay? Like it didn't have this in there, right? It just said print balance. So when he converted it to pseudocode, that's about all he had to do was put this statement in. Otherwise it looks, and he had to do the define up there. Okay, so it, and now you did use the same variables here as here. Oh, no, you didn't by accident. You misspelled principal. Does it work? See, so if they have to be the same, then this wouldn't work, right? Oh, I'm saying it does work. I'm just saying you probably don't notice that. Here, let's run it. It probably does run because you don't have to, after 1 year, the balance 50, 150. What I was saying is you see this word principal, you left the N out. So that proves that this does not have to be the identical to this.
I'm calling it
What?
a principal times 1 plus interest in the function.
Oh, yeah, so I don't know. Yeah, I don't know why it worked there. Huh? Because, yeah, it should have taken whatever this variable was and used it here. So I'm not sure. I guess Python's pretty forgiving. Because is this a global? It should not be a global variable down in here. It should be local to this main section. So I'm not really sure why it did it. It's like it took it from here without having to have it up in the function. PRI. Have you seen that before, Shelby? Do you have any ideas? Anybody else that knows Python? Have you ever seen it do it like that? So it was because it was taking it as if it was a global variable, because it just took this amount and used it there. Because his came out to 5150. Basically, to make it make sense, it should have said something like this and like this. Would have known. Let's see if this works. Yeah, it still works the same. Kitty's right. Cole, did that help? Did that make sense, what we did? Okay. All right, so what I'm going to do is I want you to, we didn't get a chance to really lecture over chapter 4, so I'm going to do that next Tuesday. And so I want you to have worked through chapter 4 and whatever exercises. And now I haven't done, we should be able to do, chapter 4 is on file handling, I think. Do as much as you can without, if you don't understand it, but this book is pretty good, except for where like that send to Twitter was. That wasn't good. That's an old predefined. I think Twitter changed too. Okay, so do as much as you can in chapter 4, but I'm also going to give you another homework problem that'll be in Evernote, and it'll be just some, I may use an if then else or a while loop this time with the function, because this one that I gave you the function, I just wanted you to understand function, so I didn't do anything else in there. Okay, so there'll be a homework problem out there too, and I'll try to get your test graded. All right. Chapter 3 is the one that I haven't done the reading quiz yet. Yes, it will be up this weekend. Thank you, Marcus. I will put that up this weekend for chapter 3, but the reading quiz for chapter 4 won't be till next week. Okay. All right, you're free to go then. Let's see where this is. Yeah, so, okay.